So now in this video we're going to look at this circuit again. So I updated the data sheet, but the main thing about this circuit is we can take one transistor and make an LED flash. And so we will look at that now. To begin with, we're going to get the multimeter and look at the voltage at the supply rail, because that is really important for this circuit. For more than just more voltage means more current. This circuit actually depends quite a bit on the voltage. So we are raising the voltage there, and when we get to about 9 volts, you're going to start seeing the LED just flash occasionally. As I raise the voltage, there you can see quickly the LED is flashing a lot faster, and we raise it even more. It's flashing even faster. So this is with a 1000 microfarad capacitor. Let's pluck it out and replace it with a 100 microfarad capacitor. It is polarized, and so let's there we go, connect it there so its leads are not as long. And let's go back to the voltage. Voltage is a little low, and I should have did this when it was still flashing. But there you can see at 9 volts it's flashing really fast. It's kind of hard to taper that off. So if you want to slow down the flashing speed, probably a higher value resistor would be a better choice. Now let's put back the 1000 microfarad capacitor, which is probably about the largest value regular capacitor most people have. So it's a fairly large value capacitor for regular capacitors. There's super capacitors out there which are have a lot more capacitance. So let us look at the voltage now. So again, it's about 9, and what we're going to do, we're actually going to pluck this. This is the 2N2222. So the emitter was to the resistor and capacitor, the base was just floating, and then the collector to the right there was connected to the anode. Long lead of the LED, other side goes to the negative rail. So looking at flat side, we had emitter, base, collector. This is backwards from how you normally wire transistors. Usually the collector is more positive than the emitter. We're taking advantage of the fact that it's not a good idea to put transistors backwards because they break down. So in any case, in this case though, we're taking advantage of that and making a use of it. So this is a 2N3904, and it has the same pin layout. Any bipolar junction transistor I've come across that starts with 2N, so this is 2N3904, that's 2N2222, has this pin layout: emitter, base, collector. So again, we're going to put the emitter towards the more positive side of the power supply, backwards from normal, and collector towards more negative. So I'm repeating that because this is backwards from most normal circuits. Usually you would put it the other way. That's one big reason why this is an interesting circuit. So, but don't get used to that when it comes to other circuits. So now we have 9 volts. The 2N2222 was flashing pretty well by 9 volts. The 2N3904 takes a higher voltage, as you can see there. So let's go to 12 fairly quickly. You can see there's still no flash, and there we go, about 12, must be at least 12.4, and so yeah, not flashing very quick. And of course we can turn up the voltage, and so we're at 18 volts now, and still not flashing terribly rapidly. So if we wanted a more rapid flash, using the resistor that we got there, we could take the 100 microfarad capacitor. So it's 1/10 the capacitance. Probably this is flashing 10 times as fast. And I can see it fluttering pretty well in person. I don't know how the camera will pick it up, but there we go. It's slowing down now, and we can see the flashes pretty good right now. So let us pop out the capacitor, and when you have enough voltage, now you can see the LED is steadily on. So what was happening was the breakdown of the capacitor. depended on, or of the transistor, depended on the capacitor. So the voltage of the capacitor rose up until it got to the breakdown point, because as I said, the transistor is reverse from how it should be. And so it's a lot easier for the base, the emitter to base, to break down when the emitter is more positive than the base, and then that will let current go through the component. And I think that's at about 8 volts for the 2N2222. I measured that in an earlier video. This is the first video I made with the 2N3904. So right there you can see that with this circuit, the 2N2222A started breaking down about 9 volts. We just saw that. The 2N3904 took about 12.5 volts. So these are the only 2 transistors that I tested. Maybe there's some that take even more. So it's breaking down because it's not supposed to conduct right now, but we raised the voltage enough to where it will. So it's an NPN type transistor, so it's also NPN if you look at it that way, but it's not exactly the same. So as we can see, when we put it in backwards, it behaves a bit differently. And you can see we got the resistor to the collector. And so I'm not going to do a step-by-step build. We got the resistor to the emitter, usually it's to the collector, 1 kilo ohm. So it's to the emitter, and then the collector is to the long lead of the LED right there. So LEDs are polarized, they only conduct in one direction. Short lead, the cathode to the negative rail, and it's lit up there because we don't have a capacitor to let the voltage change. And so we'll put the capacitor back. I'm off 1 row. That's the problem. There we go. And now you can see we have a flash. It's slower than it was before because this is the 1000 microfarad capacitor instead of the, I'm looking for another resistor, instead of the 100 microfarad capacitor. So now I decided to swap the 1 kilo ohm 1000 ohm resistor, which is limiting the current, controlling how long it takes for the capacitor to charge up. In an earlier video I saw it just charges up, well, it charges up a while, but then it just charges up a little bit to get the transistor to start conducting, and then the transistor just drains it a little bit. So the voltage doesn't change all that much at the capacitor. So we're going to swap out the 1 kilo ohm for the 4.7 kilo ohm resistor right here, and we should get about 1/5 of the flashes. It should take about 5 times as long for it to flash. And there you can see it's quite a bit slower. So you can make adjustments. Now, we just saw I got this up to 18 volts. In an earlier video I saw that I think it was for the 2N2222, we had, in fact we can get a measurement of it. What do we have there? So it's 13 volts, that must be the 2N3904. So I can tell which transistor I have by the voltage at the rail. As you can see here, with the 2N2222 at 13 volts, the LED would be flashing really fast. In fact, we can swap them out and look at that. So right there. So it is dependent on what transistor you use. So this is quite a bit faster. Let's look at the voltage across the transistor. You can see it's 7 volts across the transistor. It's going to waver a little bit, and this meter is a little slower than, like, say, an oscilloscope, so you won't see the voltage changes as much. So we have that across the transistor. That's out of 13 volts, so already more than half the voltage is stuck across the transistor. That's going to heat up the transistor a bit though when it pulses current. And then when we add the LED there, you can see we have across the transistor and the LED over 8 volts. So a lot of the voltage is being blocked. So yeah, about 8 volts. So that's the voltage across those two. So the voltage across the resistor is going to be somewhere about half that, I think. So yeah, looks like maybe 5 volts or so on average across the resistor. So you can keep lowering the resistance as long as you pay attention to the wattage. So the wattage, there it is to the positive row. The wattage is the voltage across it and the current going through it. So that applies to all of the components. As we saw, there's a voltage across the LED. We didn't look at that directly, but we looked at the LED plus the transistor. So because it's flashing, it's changing, and an oscilloscope would give us the exact changes. But you can see there's voltage across the LED, across the transistor. So when current flows through them, it's the voltage across each individual component and the current going through them. And so you just use the voltage times current for the power, and the resistor is going to be the most steady one. The capacitor doesn't really matter. It doesn't really have any resistance. And so if you use lower value resistors, you still got to be aware of the power. But thankfully the voltage is split up pretty nicely, so it's not as easy to burn them up even at higher voltages as you would think. So in any case, those are topics for other videos. We're going to keep this one simple, and let's I updated the sheet. As I said, I made a quick one a while ago when I was busy, and unfortunately the 9 volts worked with the 2N2222. So that's all I put up there was 9 volts before, but it became quickly apparent that not all transistors will start flashing at 9 volts. So really you want a variable power supply that can go up. Mine can go up to 18.6, so that's what we saw in this video. I also noted on here, because as I said before, that's an unusual setup to have the emitter more positive than the collector. We're taking advantage of something that's more of a weakness of the transistor, and that is connecting it backwards. But in this case we made use of it, and so I put 9.5 there. So yeah, I think I did cover everything on there. I threw that on there because I need to use up some more ink in my printer so they don't dry out. But in any case, thanks for watching. I will see you in the next video.